Quantum mechanics has the reputation of being one of the most difficult subjects to learn. This is not just because of the math, but also because it makes some very counterintuitive predictions. Nobel laureate and QED pioneer Richard Feynman famously quipped that nobody understands quantum mechanics. But expressing it purely in algebraic terms often doesn't help, because most students are visual learners. Consider this simple theorem, which we all learned in high school. Could you write down a proof? Done visually, it is actually quite straightforward. This classic video from 1986 provides such a proof in less than 60 seconds. You start with a right triangle. Draw a square the length of the hypotenuse, the c squared. Then make a bigger square by adding the original triangle 3 more times. Double this new bigger square and rearrange the 4 triangles. This new arrangement creates 2 new squares, which correspond to the remaining 2 sides of our original triangle, and which are equal to the original hypotenuse square. This new equilibrium holds even without the replicated triangles. That equilibrium is, of course, the Pythagorean theorem. The power of visualization can also greatly benefit the understanding of quantum mechanics. 2 critically acclaimed books did just that early in the 21st century. They came with innovative software included on CD-ROM to visualize and interactively explore quantum mechanics with an innovative tool called QuantumGL, which was used, for instance, to create this visualization of the dynamics of electron orbital states. But as is the case with a lot of great academic software, the researchers move on, the old QuantumGL program code is no longer maintained, and it becomes obsolete. While the Windows binary version can still be executed, the OS X version no longer works, nor can it be compiled with the current version of Apple's development tools. Yet, since this software is open source, this hurdle is relatively easy to overcome. But in order to truly bring this software back to life, it should be able to run in a browser, so that it could be integrated into a massive open online course or another online learning resource such as Khan Academy. While this will require some substantial re-implementation, the fact that this software uses OpenGL will help immensely, as there is now a web standard, WebGL, that all major browsers support. As this demo illustrates, WebGL gives the same level of graphics performance and 3D acceleration within the browser that standalone desktop software enjoys. This includes complex 3D real-time ray tracing, as illustrated in this water rendering demo. What we want to accomplish is to re-implement the old QuantumGL tool in a way that makes it accessible as an online toolbox, similar to the way that the Geometry Zen project allows you to interactively learn about geometric algebra. We will maintain backwards compatibility with the examples contained in the original books, and instead of being tied to a standalone desktop software, remain unshackled as a web resource that can be used whenever quantum mechanics is taught or illustrated online.
Please help us to bring back QuantumGL as a modern web tool that can be used by students and scientists alike.